Hi. Hope everyone can hear me, but let me know if you can't. Thanks everyone for being here. My name is Melissa Louie, and I'm a researcher at Sandia National Labs. Thank you to DWEA for hosting this webinar. So I'll just get started as people continue to trickle in. Again, I'm a researcher at Sandia National Labs, and I'm part of a team that focuses on interconnection standards for distributed wind energy systems, along with Michael Ropp and Liliana Bastian, and we're under the direction of Dr. Rashid Darbali Zamora. Today, I'll be presenting material we've been working on in the past year to understand and characterize the current landscape of code for interconnection and interoperability of distributed wind systems with the grid. This work was mainly done between February and December 2026, so no updates may be included, but we're happy to hear your recent perspectives and the things happening in this topic area from you too, if you have anything to share. Sorry. Also, Heather asked me to share a fun fact about myself that's not related to work, so my fun fact is that I foster dogs. Um, Okay, so here's the agenda for the talk. First, I'll be introducing Sandia's work in this space and going over the general background on this topic, including overviews of the IEEE 1547 standard series and UL 1741. And then I'll talk about current challenges and efforts to bridge the gap, challenges and potential strategies for addressing them, including examples of current and ongoing efforts in this space. Next, I'll summarize potential paths forward for addressing these challenges, and I'll provide an overview of some ongoing and planned efforts in this space. I'll aim for around 45 minutes of talking with pauses for between some of the sections, and I'll also try to leave some time for questions and discussion at the end, but feel free to leave a question in the chat as needed. So first, I'll provide an introduction to our work at Sandia. Um, Sandia has expertise, experience, and ongoing work in topics related to distributed wind energy interconnection. This includes efforts in standards, stakeholder engagement, and equipment performance testing. So for standards, our team has participated in the RAISE program. This focuses on rural and agricultural renewable energy, and we were looking into the role of standards in that space. Sandia also participates in all aspects of the IEEE 1547 standard series, including through working group participation and leadership. And in terms of stakeholder engagement, the Sandia Distributed Wind Team regularly attends the annual DWEA meeting, and we hope to continue to maintain communication with and be a resource for DWEA members. In terms of distributed wind equipment performance testing, we maintain and operate the Distributed Energy Technology Laboratory. This is the facility we use for commercial inverter performance testing, power, hardware in the loop testing, and development and testing of new distributed energy resource management systems. As a quick plug for looking at some of our recent work, at the beginning of the year, we published 2 reports based on last year's work. So the first one is an overall review of distributed wind interconnection technology and standards, and the content is similar to what I will present today. The second is the report for the RAISE project I just mentioned. Both of these are open source and can be found at the Office of Science and Technical Information website. Now I'll move on to provide some background and context for this work. So here in this presentation, I will refer to distributed energy resources as energy generation or storage technologies that are interconnected and interoperated with the distribution grid. And I'll focus on distributed wind energy systems, of course. So when distributed wind system owner apply to interconnect their systems to the main distribution grid, they may be subject to compliance with certain regulatory standards. The 3 main standards I will touch on are IEEE 1547-2018, IEEE 1547.1-2020, and UL 1741, and UL 3141 is also included here for your awareness. These requirements are written by standard committees like IEEE, and in practice may be voluntarily adopted by authorities having jurisdiction. These authorities may be at the federal, regional, state, utility, or other level. One major challenge that has continued to emerge as the standards are updated periodically is the high economic and time cost, often associated with achieving compliance for wind energy generators in particular. Development of IEEE 1547-2018 compliant inverter for distributed wind applications is largely seen as a market risk, which causes slower development of energy inverters for interconnection than other DERs, such as solar. Overall, the current regulatory and market landscape presents barriers for development of interconnected distributed wind projects. Standard technical specifications can ensure that DER systems and subsystems operate and communicate as anticipated. For example, the standards are rigorous and include requirements for inspection of corner cases to thoroughly test a range of conditions on the device in question. This can be beneficial to multiple stakeholders. For example, it provides a check for inverter manufacturers or vendors to ensure that their equipment has been rigorously tested and will function as expected. It also provides confidence to utilities that minimum technical capability and performance requirements will be met by the interconnecting DERs. This standardized performance can help maintain safe and consistent operation of distributed energy resource systems that are interconnected with the main grid. There are multiple stakeholders that play a role in development, adoption, enforcement, and compliance to standards. First, standards publishers, such as IEEE and UL, are responsible for developing these standards and updating them periodically. Many standards working groups are made up of researchers and people working in the DER industry, and there are also regulatory agencies at different levels of governance which may opt to adopt and require standards. These agencies are typically in close contact with grid infrastructure owner operators and the DER industry players to support various stakeholder goals. Grid infrastructure owner operators, mainly utilities that can have a variety of ownership and leadership structures, may also have regulation enforcement responsibilities, depending on their relationship with the overseeing regulatory agency. And I'll provide an example of this later with California. These stakeholders are typically responsible for and would have a direct interest in ensuring compliance of fielded and interconnected DER projects with any regulations their AHJs and or they themselves set for DER interconnection on their equipment. Finally, the distributed wind industry currently has relationships with and continues to have opportunities to work with each of these stakeholder groups. So here I'm focusing on product manufacturers and original equipment manufacturers of equipment used in distributed wind energy systems. This can include power converters and also including wind energy system product developers in this group. So in this framework, distributed wind product manufacturers are compelled to ensure compliance of their devices with the standards to which they'll be held for fielded and connected systems. Industry stakeholders currently do and have further opportunity to provide feedback and input to each of these other stakeholders that have more regulatory roles and work towards improvement of distributed wind interconnection project outcomes, while still supporting other stakeholders in maintaining stable and consistent grid operation. So for example, as I mentioned, distributed wind industry stakeholders may join standards working groups and submit requests for new rulings to their authorities having jurisdiction. So now I'll start going over the main standards that I'll be focusing on in this presentation. First, the IEEE 1547 standard series contains multiple parts, two of which I will talk about here. So IEEE 1547-2018 specifies standard capabilities of DERs for both power and data communication interfaces that should be met for grid interconnected systems. These capabilities include maintaining certain voltages and frequencies when entering service, reactive and active power control, meeting certain parameter limits for synchronization, and protecting against unintentional islanding. This is when a portion of the grid that has been disconnected from the main grid continues to be energized with DERs, and it's not something that we want to happen. So IEEE 1547.1-2020 then provides specific test procedures and methods to meet the performance requirements in IEEE 1547-2018. These tests include, but are not limited to, type tests, production tests, commissioning tests, and periodic interconnection tests. Overall, the IEEE 1547 series provides standard performance criteria and tests for DER systems that are to be interconnected and interoperated with the main grid. An additional standard that closely works with and supplements IEEE 1547 is UL 1741. This standard includes additional details for the testing methods and procedures in IEEE 1547 and introduces a certification for grid interconnected DERs. These topics include the physical and electrical construction of the device, performance requirements and associated testing, electrical, environmental, and other ratings, and manufacturing and production tests. The standard applies to equipment that includes power inverters and converters, charge controllers, AC modules and PV modules with integrated electronics, rapid shutdown equipment, and general interconnection equipment for rotating generation. Overall, UL 1741 supplements and provides details for the IEEE 1547 requirements and tests. It also introduces a certification for grid interconnection devices. So UL 1741 also contains supplements that are continually updated over time, including the two that are shown here. Supplement A was published in 2016 after the publication of edition 1 of UL 1741. It contains performance tests for capabilities including anti-islanding or unintentional islanding protection, voltage and frequency ride-through requirements, ramp rate requirements, and volt-var mode requirements. And the more updated Supplement B was published in 2021 with the publication of edition 3 of UL 1741. This more recent certification has updated type tests as well as advanced grid functionality requirements that were not contained in Supplement A. So I already went briefly into how standards such as the IEEE 1547 series and UL 1741 are adopted and applied in practice, but here I'll provide a little bit more context. So authorities having jurisdiction, again, is a term that may refer to regulators, but also in some cases refers to other stakeholder groups, and this can include utilities. So AHJs can select standards to adopt as requirements for DER developers to comply with when interconnecting their projects to the distribution grid. One example of an application of these standards is California Rule 21. This is California's interconnection tariff and is set by the California Public Utilities Commission. First, this rule is technology agnostic, so it generally applies to DERs, including distributed wind energy systems. It's also generic and leaves some responsibility for investor-owned utilities serving areas throughout California to adapt to the general requirements for their own equipment. So some examples of the requirements included in California Rule 21 include requirements around device capabilities, affordability, and transparency. In terms of device capability, one example is that the rule encourages replacement of non-smart inverters with smart inverters once they reach end of life in legacy or already installed DER systems. And you can see how Rule 21 is also updated accordingly as standards are updated. So for example, in 2016, the rule mandated IEEE compliant DER interconnection devices. And then when UL 1741 Supplement A was published in 2016, new inverters were required to be certified to it. And then again, when UL 1741 Supplement B was published in 2022, new inverters were now required to have this new certification. So additionally, Rule 21 includes efforts related to improving affordability of interconnection projects, such as requirements for the utilities to conduct cost envelope studies. Another example is that Rule 21 has made efforts to improve transparency of the interconnection process, for example, by requiring utilities to host workshops to explain the application process for interconnecting DER projects. So we tried to summarize a simplified version of the process for developing and commercializing a DER power converter in this slide, but in practice, there may be multiple pathways that manufacturers take to get to device implementation in fielded and interconnected systems. So in this example, during the development stage, the manufacturer designs and develops the product and tests it for certification with UL 1741 Supplement B. Typically, this testing and certification is conducted by a nationally recognized test laboratory. If the product fails any of these tests, the manufacturer would likely have to make adjustments to it until it passes all the tests and can be certified. And at that point, the product can be commercialized, manufactured, and used in distributed wind projects intended for interconnection with the main grid. From the stakeholder engagement we did at the Distributed Wind Energy Association conference last year, we found that the main bottleneck for getting certified distributed wind interconnection devices to the market is this testing and design iteration process. So we heard that the process is costly and time consuming, which means that manufacturers may pivot to focus on options that are currently more financially viable, such as solar interconnection products. And in general, they may be and unable to pursue distributed product commercialization due to a lack of ability to support the product certification process. As a way to give a little bit more context for the way that these standards have been applied in the past. So there have been some commercialized certified wind turbine products. One major example is SMA's Windy Boy inverter, which was certified to UL 1741 at the time it was on the market. And that does not necessarily mean it is compliant with the current versions of the UL 1741 certification. This inverter operated over a range of voltages, DC power inputs, and AC power outputs. The inverter is not manufactured or sold anymore, in part so the company could pursue more profitable, viable markets, and is currently a leader in solar inverters. And then this is one update that we did include since January of this year when we published our report, but Northern Power Systems recently obtained electrical certification to UL 1741 Supplement B for this converter. This is the NPS 100C wind turbine power converter. And before this product was certified, there were no wind turbine power converters that we were aware of that were certified to UL 1741 Supplement B. So let me just take a pause to see if there are any questions here. I think in the chat, yes, I will throw the report links into the chat during the Q&A. And then, yes, we will put the slide deck. We will share it with participants. It should also be on OSTI soon. Are there any other questions while we're here? Okay, I'll continue, but yeah, feel free to speak up. So now I'll move on to talk more about some of the current challenges and efforts we came across while looking into this area. So as part of our work looking into these challenges, as I mentioned, we engaged with attendees at the 2025 DWEA meeting in February last year. So we spoke with stakeholders from several companies and focused on understanding challenges, priorities, opportunities, and recommendations regarding making the distributed wind interconnection landscape more accessible. We found several central themes through these engagement efforts. So for many distributed wind device industry stakeholders, developing these interconnection devices that are compliant with the technology agnostic standards has been technically difficult. In particular, we heard a theme that these standards are easier to comply with for certain energy system types, such as solar, and more technically difficult to comply with for wind energy. So as I mentioned on a previous slide, wind energy interconnection device manufacturers may have to dedicate more financial and time resources to achieve standard compliance, which has been reported in some cases to make compliant product development cost prohibitive. Overall, these factors lead to a perceived market risk of pursuing development of compliant distributed wind interconnection devices, and this contributes to the bottleneck of development and commercialization of these products. Then after engaging stakeholders and listening to this initial feedback, we did a deeper dive into these themes, including the technical challenges that were mentioned. So the IEEE 1547 and UL 1741 standards were written to be generic to a range of DER types, which includes distributed wind energy. And from a technical standpoint, wind turbine active and reactive power can be highly variable just based on the variability of wind. And this can make it challenging to control power and voltage. In addition, the high inertia of wind energy systems may necessitate more costly and or complex controls to meet requirements such as those regarding rapid power adjustment in out of range voltage or frequency scenarios. Similarly, power ramp rate requirements may also require specific and complex control capabilities. From a system integration standpoint, there is the possibility that isolated DER interconnection devices may also pass UL 1741 tests, but not guarantee that the fielded system with that device installed would pass. Finally, IEEE 1547.1-2020 explicitly refers to certain technologies, including distributed wind energy, but in some cases there may be technical challenges when applying this standard to the particular energy system in question. So for example, in some cases, induction machines and synchronous machines have the same requirements in this standard. Again, adding technical complexity to meet standards can add time and cost to the product development process. Technical challenges can be overcome, but as stated, oh, sorry, go ahead. So technical challenges can be overcome, but as stated, they may come at steep financial and time costs. So some of the stakeholders we talked to mentioned that the certification process can cost several $100,000. And if the cost is passed to the consumer, then these wind energy interconnection devices end up being more expensive for purchasers than other DER devices. The timelines for certification were cited to take at least several months. Additionally, many product developers have no other option but to outsource testing to certified labs since open source or commercially available testing platforms may not keep up with standard updates. If testing platforms were available, manufacturers would potentially have the option to complete unofficial in-house testing to understand the status of their products in regards to standard compliance before undergoing the official certification process with a nationally recognized test lab. These challenges all contribute to the small market size for wind energy power converters, which sort of leads to a chicken and egg issue because there's currently insufficient investment and support in the market for these devices to be as commercially viable as some other products. But investment and support are also viewed as high risk because the market is currently small. These challenges overall may result in a situation where small manufacturers may not have the resources in general to support the certification process, and large manufacturers may prefer to pursue more profitable products, with SMA being one past example. All of these factors contribute to the lack of certified and commercially available wind inverters. But before I go into the next section where we'll discuss proposed paths forward, are there any questions? Okay, I'll move on. So using the findings. Oh yeah, go ahead.
Yeah, doing pretty good. How about you?
He accidentally unmuted himself.
No.
But we have a small group here, so if anybody does want to come off mute, you're welcome to do that. And you'll have some time at the end, right, Melissa, for more
Yeah,
general discussion? Okay, great.
yeah, I think it might even be before 45 minutes. So yeah, be quick.
Doing great.
Thanks. All right. So using the findings from this review, we came up with several proposed paths forward to address these challenges and support distributed wind interconnection from the interconnection device standpoint. So this is a lot of words, but bear with me. As shown in an earlier slide, there are multiple stakeholders that play a role in this space, and there are potential actions that each can take to work towards collective needs and goals. So please note that these are not meant to be official recommendations and that they're just meant to provide a general idea of recommendations we have heard or explored in this space that relate to the challenges that we mentioned earlier. So our first proposed path forward is from the standpoint of publishers of standards. So for example, some wind energy integrators are looking into adjusting solar energy inverter parameters for use in wind energy systems with the idea that there could be an opportunity to streamline certification processes for inverters that are already certified to solar generation, but are instead integrated into wind energy systems. There's also a question of whether small distributed wind projects under a generation capacity threshold can be exempted from certain criteria. So for standards organizations to adopt changes like exemptions, it would be important to prove that, for example, exempted wind energy systems could still be good citizens of the grid. Our second proposed path forward is from the standpoint of authorities having jurisdiction. So these are, again, the stakeholders that may opt to adopt standards as regulation in their areas of purview. Their role may involve providing guidance research support to bridge gaps between standards compliance and challenges faced by the distributed wind industry regarding interconnection. So one major challenge cited in our stakeholder engagement efforts was that certified product development is time consuming and sometimes the timeline between updates of standards is not much longer than the time it takes to develop and commercialize a certified product. This situation may lead to high cost products becoming obsolete or non-compliant soon after commercialization. So in response to this challenge, it may be a possibility for AHJs to work with local wind energy facility operators in their states or in their regions to allow products with previous certifications until the product market with updated certification has time to catch up. And actually in some work that we're currently doing, looking at different states and their regulations, this is something that we have seen some states doing where they allow for a previously published certification to be considered compliant until there's commercial availability of the current compliant devices. AHJs may also have the agency to explore alternatives to requirements that are specifically costly in practice. So for example, in California, PG&E requires DERs to undergo an anti-islanding screening test or the risk of islanding test, and systems that fail the test must install a direct transfer trip device, and that would automatically isolate the generation section of the DER. We've heard that this requirement has implementation has been reported as being costly, and in response, CPUC has created these unintentional islanding working groups to look into technical and non-technical alternatives, and these could then potentially be adopted as options by HJs accordingly. Again, with the non-technical alternatives, these might include something like insurance, and that would allow the distributed wind owner operator to assume risk rather than having the utility assume the risk. And in general, the utilities may or may not be in favor of this idea because unintentional islanding from a technical perspective can still damage other customers' equipment, but insurance may potentially be a way to at least reduce the risk overall. As with the proposed actions for standards organizations, these potential paths forward here would require understanding and incorporating some perspectives from the HJs who may not have an interest in making requirements less strict once they've already been adopted, namely UL 1741 Supplement B. And AHJs may have different priorities in the distributed wind energy industry, with grid reliability, safety, and financial viability being likely priorities over adding interconnected distributed wind. But there's still some things that the two stakeholders groups can do to improve the distributed wind outcomes. And then the other two stakeholders that I'll talk about are research institutions and then the distributed wind industry stakeholders. So these research institutions, like Sandia Labs, may also play a role in supporting interconnection for distributed wind energy facilities. Though through looking into challenges and opportunities that other stakeholders may not have the capacity to do a deeper dive into. So forming a holistic understanding of stakeholder perspectives on all sides may help facilitate conversations to work towards improvement of the landscape for all stakeholders. These institutions may also provide services for testing commercial power electronics equipment, for example, through funding from the Competitiveness Improvement Program. This is a program funded by the Department of Energy, and it partners industry stakeholders with national laboratories for this type of testing and development work. It may also reduce burden on manufacturers because it would be less costly than iterating on a product through the official certification testing pathways. And it may also reduce the burden of parsing through testing results and analytics for manufacturers. Additionally, research institutions can help develop testing platforms that work with updated standard criteria to provide in-house testing capabilities to manufacturers. Research institutions may fit well into this role with the distributed wind interconnection ecosystem because of bandwidth and expertise, and it is important for research institutions to remain unbiased and as objective as possible in this work. Of course. Finally, distributed wind energy stakeholders have an opportunity to work with the aforementioned stakeholders to communicate unique challenges and barriers to distributed wind interconnection and interconnection device commercialization. So growing and maintaining relationships between stakeholders may help find solutions that account for various priorities and goals. Wind energy stakeholders may also conduct research as they're able to, like the research I mentioned that some wind energy system integrators and manufacturers are conducting with solar certified inverters and wind energy generators. As discussed, these stakeholders may be resource constrained and may prioritize economic opportunity when working on product development and commercialization. And then I'll briefly mention some ongoing and planned efforts in this space that we're aware of, but it's not an exhaustive list of the work happening in this area. So earlier I mentioned California Rule 21. This rule was written again under the purview of the state level California Public Utilities Commission. It currently requires DERs to have unintentional islanding protection. The CPUC gives the California utilities the option to implement this requirement in their own Rule 21 tariffs. So one example of this application that I touched on is that PG&E requires this risk of islanding study. And systems that fail the study must install direct transfer trip capabilities. We've heard that both the risk of islanding study and the installation of direct transfer trip can be prohibitively costly for project developers. So to address this challenge, the CPUC established an unintentional islanding working group to look into interconnection barriers for distributed wind energy owner operators and published findings, including preliminary research into alternatives. In addition, last year, the CPUC opened a proceeding for Rule 21 to address the ongoing concerns of distributed wind developers regarding the costliness of the direct transfer trip requirements for unintentional islanding protection. As stated by the wind industry stakeholders who initiated this proceeding, the current version of California Rule 21 requires UL 1741 Supplement B certification, and in practice, this requirement necessitates the development of bespoke wind energy inverters that are costly and time-consuming to develop and commercialize. And in terms of research efforts, Sandia Labs has been and will continue to engage in power hardware in the loop testing for pre-commercialized power converters. Sandia researchers are also working on development of a testing platform called the System Validation Platform. This is open source and has been well developed for use with solar generation simulation inputs. And then updating this platform for compatibility with wind energy inputs could help support pre-certification in-house and also with in-house product testing for manufacturers. So DER Security Corporation also has a testing platform. This is called LabTest. It's commercially available and was updated to certify wind energy systems to UL 1741 Supplement B last year. From the regulatory landscape, Sandia will continue to grow our understanding of pain points in the distributed wind interconnection space, including through further review of the IEEE 1547 and UL 1741 standards. We'll also continue engagement with utility and regular stakeholders and with the distributed wind industry. So here are some more details about Sandia's plan review work. So for the remainder of this fiscal year, we'll engage with utilities and regulators to understand their needs, challenges, and general experiences with wind energy interconnection. We'll pair this engagement with a review of individual state-level regulatory structures for IEEE 1547-2018 adoption, and we'll have an initial focus on states listed in the slide. So California, Texas, Oklahoma, Michigan, and Alaska. And we'll also plan to review international standards related to DER and wind energy interconnection to understand how these regulations may differ or have similar aspects to the IEEE 1547 and UL 1741 standards. And I'll end with some conclusions. So 3 major highlights that we want to emphasize from this work. As mentioned, right now there are some challenges in the current distributed wind interconnection device market. Wind projects may be stalled or not approved by authorities having jurisdiction if they are not compliant with standards like IEEE 1547 series or UL 1741. At the same time, there's this chicken and egg issue where the market for these compliant and certified devices is very small, leading to certification often being a costly and time-consuming process that may not feel worth it to manufacturers. But despite these challenges, there are opportunities for expansion of this market and improvement of distributed wind interconnection outcomes, especially through continued and increased engagement and interaction between stakeholders in this space. Feedback from distributed wind manufacturers to standards publishers and regulators may be greatly useful for improving distributed wind product commercialization and implementation outcomes, while also respecting grid reliability needs and priorities. Thanks for your attention. Ended a little early, so we'll be happy to take your questions either here or offline if you want to get in contact with us after. I think some of my other team members are also here, so if you have a question I can't answer, feel free to ask them too. Thanks.
Melissa, this is Mike Berge. On an earlier slide, it said that through discussions with industry stakeholders, you determined we expressed the view that the standards were more difficult for distributed wind than they were for solar. But I think I don't think that was certainly not what I meant. It's the same standards. We have to requires the same testing for distributed wind and solar, so it's not more difficult to obtain for distributed wind, but for the reasons that you've stated, it's more burdensome for us. But it's not technically more difficult. I think that was the part that I didn't quite agree with.
Okay, sounds good. Yeah, thank you for clarifying that.
Hi, Mike. I think that when we did the interview, our perspective or what we got from those interviews is that it's more difficult not on the technical side. It's more difficult on the whole process. But it's not because the technology is out there and the distributed wind industry can achieve it and the technology works and it's compatible. It's more on the hurdle of it.
Right. I agree with that, of course.
So we'll make sure to make a correction.
The other thing on the for the ongoing work, the states that you're going to look at the regulatory process, there were a couple that sort of surprised me. Michigan, um, another one. Anyway, I would California, yes. I don't think you need to do Oklahoma because SB is not required out here, as far as I know. Todd may know differently, um, but I would certainly add New York to that list, and others may have some suggestions. Texas also, I'm not sure. We need Texas. It's not a big market for distributed wind.
Hi, Mike, Rashid again. We appreciate any recommendations that you can provide in states that the distributed wind industry would be interested in us looking into. We selecting this states was based on a analysis that we did on where distributed wind was being deployed, where there are standards, where there aren't any standard requirements, and how would that look like. But it's not set in stone, and we do want this to be beneficial to the distributed wind industry. So if you or any member would like to provide more recommendations of states that we can look into, we would really appreciate that.
Yeah.
So thank you.
Yeah, from the DWEA perspective, we're either working on or thinking about trying to get incentives put in place or back in place in California, New York, and Massachusetts. So those are three that we'd like to have on the list, in addition to any others you feel are worthy.
Okay, we will do that. We will do that.
I also see that there's a question from Chris and some discussion regarding proposed generation limits. And Mike jumped in here. Do you want to say anything about that, Mike?
Hey, Melissa. Nothing beyond what's in the chat. I mean, if folks want to discuss that further, would be definitely interested to hear.
Well, DWEA, represents behind the meter of all sizes. So, and you've already, of course, the SB is directly applicable to smaller barriers, is directly applicable to smaller systems and medium systems, but the transfer trip barrier and the problem with approval of induction generator-based systems, you've already listed, and so. I think from our perspective, we prefer no limit, but just, a concentration on the particular pain points at the scales. We have members like Foundation Wind that are doing multiple multi-megawatt turbines, and they have, we're as interested in their barriers as we are in the stuff that Berge Wind Power and other smaller turbine manufacturers face.
Oh, do we have some more questions? Go ahead.
No, I was going to say my point about conversations around limits was not that there are conversations or that there is a number out there, but having been still going through this in the solar space, it's like, okay, hey, the conversations help socialize and actually define sometimes pain points and stakeholders with more skin in the game who should help set eventually a limit. And I propose there should be exemptions, but clearly, from Interstate Renewable Energy Council's point of view, it must be with safety first in mind and based on data and not on who owns the system and we're afraid and therefore we're going to make, a broad brush statement on limits or no limits. I think it just has to be something based on reality in the engineering and the grid system.
Yeah.
So I know there's no limit right now. I just wondered if there were some numbers being talked about to sort of soften the space and prepare for actual conversation and data sharing on it. But thank you all for your indulgence on that.
Be a good problem.
So, Chris, a couple of comments on that. First of all, distributed wind it varies in some important ways from solar, and the standards were written for solar. For example, the SB requirements largely came from concentrated applications of solar, so you could have, dozens to hundreds of systems on a single feeder. And so the utility's ability to control that and make sure that there are no adverse effects on the grid led to some requirements that really don't address concerns that are possible in the distributed wind space. We don't go into neighborhoods. They're spread out. There are very, very few per feeder. And so the risks to the utility, to the grid are far different and far less. And so, that I think we've talked with Sandia about, sort of identifying these differences, and then of course the much more random nature of wind as a energy input, which makes trying to create a stable island during a grid outage technically extremely difficult. So whereas solar is a more steady input and has a greater risk in that area. There are some other things as well. And, we're really looking forward to working with the national labs and particularly Sandia to identify and white paper these differences in support of, lessening the burden on manufacturers, because it really is keeping
Sure.
products off the market.
Yeah, that's cool. And I understand they're completely different technologies. Apologies. I didn't mean to take the conversation off track.
Yeah.
I was just curious.
Yeah.
Thank you, though.
Good question here from Chris Connor. Melissa, could you or Rashid address that? About 1741.
Yeah, so for supplement C, I also saw the same, that it's focused on EV chargers and V2G. I don't have access to it right now, but I think the scope is not related to distributed wind from what I've seen so far. But yeah, Rashid or Mike, if you know anything further, please jump in.
My response is the same as Melissa's, but I'll defer to Mike in case he has any comments.
Really nothing additional from me, Rachid. That is accurate that it was just released. And I know a lot of the conversation was around what do you do with a mobile resource? In other words, V2G.
Guessing Brent Somerville has a copy. Maybe he can look through it. And we put in the chat, David, do you want to mention the next upcoming webinar?
Yeah, so June 25th at 1 p.m. Central, we have the next webinar in this series called AI-Driven Controls for Distributed Wind. And you'll see the link, the registration link for that in the chat. We'll also be following up to all attendees here with the registration link shortly.
I'll add to that a little bit more, just a little bit more details. The next webinar will be looking at AI-driven power management schemes, specifically looking into distributed wind's participation in power management. We did or Sandia did a field demonstration that combined distributed wind and solar, and to serve a experimental data center testbed. The goal was looking into coordinating distributed wind and other assets for voltage regulation and ensuring voltage regulation by controlling the distributed wind power converter. So stay tuned. We'll be sending out a flyer and an invitation soon. Heather and DWEA will, and we hope to see you there.
Great. Any last questions on today's topic? I'm glad we had a good turnout. And just thank you to Sandia for inviting DWEA to co-host this with you. I'm glad you're able to do this work and can continue the focus on distributed wind. So let's see, anything else in the chat? Now's your chance for last. And thank you, Melissa, for making it a little more upbeat at the end.
Sure. Thanks for having us.
I wanted to end on a high note, looking forward. So yes, we will definitely be emailing it out. I don't know if we have permission to post it on the website. We'll circle back on that. I'm assuming, Rashid, you have to get approval for us to post it, but we can email it for sure.
But Melissa, can you remind me, is this webinar on OSTI?
It hasn't been uploaded yet but I'll check because it should be soon. But I'll double check and let you know and let Heather know.
Thank you, Melissa. Thank you, Heather.
All right. Well, everybody has a little 10-minute break before their next thing. You talked so fast that we had plenty of time. So thanks again, everybody, for joining, and we'll see you next time.
Thanks,
you.
Everybody.
Take
Thank
care.
you.
Thank you. Thanks.